Hello, and welcome to today's webinar, How to Avoid AI Failures. My name is Sriram Ramanathan, and I'll be your host today. Our speaker today is Cole McCollum. Cole is an analyst at Lux Research and contributes to our research in the area of sensing technologies and artificial intelligence, or AI. Cole recently developed an AI decision framework that allows clients to pick and choose AI projects that offer the highest probability of success. He published this framework in a recent report, which, by the way, has been one of the most popular reports on our member portal in the recent months. Today's webinar is a sneak peek into that report. During the webinar, if you have any questions for Cole, please enter them into the questions box on your screen. We will have time to answer some of these questions at the end of the presentation. Before we get started, I want to highlight a few challenges that are unique to digital transformation. Technologies and consumer needs in the digital space tend to evolve much faster than other traditional areas, thereby making it very hard to stay ahead. On top of that, the fact that because barriers to entry are very low, there are thousands of vendors in this space, making it very difficult to pick the right partners to work with. And finally, digital is all about interconnectedness. Interconnectedness between different sectors and markets, which on one hand offers a plethora of opportunities for companies, but on the other hand poses new threats from unknown players. All of it is very difficult to understand. At Lux, we partner with our clients to help them make smart decisions when it comes to innovation and growth. Clients get access to our primary and secondary research to our member portal, can engage with technology experts like Cole and others on the team, and on top of that, we also offer custom consulting solutions. Today, Cole is going to demonstrate how we help our clients. With that, I would like to hand it over to Cole McCollum.
Thank you very much, Sriram. So as Sriram mentioned, today I'm going to be talking about how to avoid AI failures so that you can really deliver on all the promise that has been made surrounding artificial intelligence and machine learning. So to lay out the agenda for today, I'll start by highlighting, what the opportunity with AI is and really what's at stake here. But on the other side of that, I'll also describe the challenges that many deploying AI today are facing. I'll then introduce a framework that can help you be more successful with AI and in your AI initiatives. And then finally, we'll finish by applying this framework across several industries to show how it can be used to inform decision making. So we'll begin with section 1. We've really seen interest and investment in AI continue to reach new heights. So in 2019, we saw that investment into AI and machine learning startups surpassed all of the funding in 2018, actually breached $30 billion in 2019 alone. And with numbers this high, many are wondering, is there just a lot of hype in this space? But they actually make a lot more sense when you look at the broader opportunity and the broader context here. So firms like McKinsey Global Institute have estimated the AI opportunity to be around $13 trillion by 2030. Other firms like PwC have estimated it to be closer to 15.7 trillion by 2030, which they noted was more than the current output of China and India combined. And whether it's $13 trillion or closer to $16 trillion doesn't really matter, but what does matter is that this is likely to be one of the biggest, if not the biggest, opportunities of the next decade. And we've seen major players from nearly every industry start to jump at this opportunity. So on the left here, we have, if you look at acquisitions, in 2019, we saw companies like Facebook and Apple acquire companies to enhance some of their core product offerings. Other companies like Uber and Tesla acquired AI startups to enhance and accelerate some of their autonomy initiatives. But what is more surprising and in some ways more interesting is that companies completely outside of the traditional tech industry are starting to make big moves into AI. One of my favorite examples here is McDonald's, which made two large acquisitions of AI companies in 2019. One being a company called Dynamic Yield, which offers personalization AI, and they acquired them for around $300 million. Another company is called Apprente, which they acquired to help automate their drive-through ordering process using technologies such as speech recognition. So clearly, companies from every industry are starting to think really deeply about how to make the most of the AI opportunity. And for some industries, AI is likely to be much more than just an opportunity, but actually imperative to future success in that industry. We have a quote here from Elon Musk, who likes to say, "If your competitor is racing to build AI and you don't, they will crush you." And while there may be some truth to that in the long term, what we're seeing today is that navigating the AI landscape has truly been a bit of a minefield. For example, we've seen self-driving. We were promised autonomous vehicles on the road by 2019 by major automotive companies, but almost every one of them has now walked back on those statements to say that it's going to be much further out than they expected. We've seen applications in healthcare come up short and not perform as expected. And if you just look at the broader AI landscape, you start to see that deception and confusion really are the norm here. A recent study came out that showed that 40% of European startups that are classified as AI companies don't actually use any artificial intelligence. So clearly, this is a tricky terrain to navigate. And the big question here, is what is your AI strategy? Because on one hand, you have probably what is likely to be the biggest opportunity of the next decade. But on the other hand, you have this really challenging landscape to navigate, where it's hard to select the right developers to work with, as they all claim to provide similar capabilities. But even more fundamentally, at the very earliest stages of a project, it's hard to select the right problems to work on and the right timelines to assign to the solutions. And even major technology companies are struggling with this. So for companies which do not have AI as a core competency, there really is an even greater chance for failure here. And to address this situation, we can take a page from Charlie Munger, who is the longtime investment partner of Warren Buffett, and one of my favorite thinkers who always recommends inverting such difficult problems when he says that many hard problems are best solved when they are addressed backward. And what this means when it comes to AI is that you really want to start with the outcome of AI, not with the tool itself. So this means not deploying AI for the sake of deploying AI or the sake of deploying machine learning or deep learning. What you really want to start with is what you can actually accomplish with it. And this is because your stakeholders simply, whether they're your internal customers or partners, they don't care if you're using deep learning or you're using a more basic regression analysis in Excel. What you really need to know is what AI can and cannot do for them. So with that in mind, I want to introduce a framework that we've developed that starts with this outcome-focused approach to AI. And regardless of what your AI initiative is, whether you're starting an AI project or you're investing in AI, this framework can really help increase your chances for success. So the first critical question to answer here is, can your outcome be achieved with AI? And this is a deceptively simple-sounding question because many AI applications all have or fall under the umbrella of AI, but they actually have very different AI requirements. And so what we've developed is an AI framework that determines the level of AI required to accomplish a given outcome or to accomplish a task. And on the top right of the quadrant, we have the highest level of AI required, and on the bottom left would be the lowest amount of AI required. And there's really two dimensions to this framework here. So on the vertical axis, we have the amount of reasoning required, and this is the amount of critical or in-depth reasoning involved when a human accomplishes that same task. So this can range from basic pattern recognition capabilities, things like detecting obvious visual defects, facial recognition where you could instantaneously identify a pattern, to deep reasoning capabilities, which tend to be slower, more deliberate, long-term planning and reasoning capabilities. So you could think about things like writing software or writing a book. It's much more than just sort of recognizing a pattern. It requires multiple cycles of thought. It would be one way to put it. On the horizontal axis, we have the environmental complexity. And this is really the complexity of the operating environment or the data that need to be processed to accomplish the task. And this can range from simple and constrained environments, things like factories where there's consistent lighting and consistent conditions day in, day out, to really complex and dynamic environments. Things like driving a car where the conditions are always a little bit different, or organic systems like biology where there's just the inherent complexity and non-linearity in the system. And what we've done is analyzed dozens of applications and applied them on this framework, and we see 4 distinct quadrants start to emerge. So applications that fall into the bottom left quadrant tend to be much more mature, but the impact is a bit more isolated, whereas applications in the top right quadrant tend to be long shots, so they'll take significant amounts of further development, yet the impact of such applications tend to be broadest in terms of what can be tackled there. And then applications that fall in quadrant 2 are quickly maturing, whereas applications that fall into quadrant 3 are just beginning to emerge. So to show you how to use this framework, we'll go through an example here, which is digitizing and interpreting documents, so automatically interpreting images of typed or handwritten text. And this is a really classic example of an AI application. One of the first steps that you would need to do to digitize and then interpret the document is just get it in a machine-readable format. So if you have an image of a bunch of text, of typed text in this case, this application would fall pretty squarely into quadrant 1 because it's a fast pattern recognition task, as if you compare it to how a human does it, they could do it with nearly instantaneously with really high consistency. And the complexity is fairly constrained because you're looking at a single source of data, there's inherent structure in the document due to it being typed, and there's often a limited number of fonts to pick from, so it really constrains the application into quadrant 1. And we can contrast this with trying to recognize handwriting. And this is still a pattern recognition task if you compare it to how a human does it, but it does require a bit more reasoning and understanding capabilities for things like typos or where things are crossed out. You have to understand a little bit more of the context. But where it really differs from typed text OCR is in the environmental complexity. Where you see that there's little document structure, especially where there's no lines in the document or things like that. And there's extremely high variability in styles because everyone has their own unique handwriting, which makes it a much more complex and dynamic environment. One way to use this framework is to think about, if I wanted to deploy something tomorrow using AI, how could I constrain this application to make it more mature? And that's exactly what we've done here. And one way to do this would be to look at handwritten forms. And so this adds some more structure to the document, which constrains it and then brings it into quadrant 1 of this framework. And this is a much more mature application and something you could deploy tomorrow if you wanted to. If we wanted to go a step further and once we've digitized information but actually understand what's going on in that document, this would be an application that falls into quadrant 4 of this framework because this requires both high levels of pattern recognition and reasoning because to actually understand the text, you're not just recognizing a pattern on the page, but you have to draw inferences between, a broader context of knowledge, draw conclusions between other documents and background information and so on and so forth. So this would fall higher on that reasoning required scale. And this is also a really complex and dynamic source of data and an environment because there's such high variability in the style and usage of language here. Again, if you wanted to think about constraining this to make it more mature for today's AI tools, you could think about an application like just trying to understand the emotion in text, because this is something where the answer really is on that page. So you're trying to just recognize a pattern right there in the text. You don't necessarily need to draw. You don't necessarily need to reason between a broader set of knowledge. So this is a pattern recognition task, and this greatly constrains the environmental complexity. So this is an application that would be between late development to approaching maturity here. And the key takeaway from this exercise can really be that can be seen that AI outcomes fall all over the framework. And just because two applications of AI are both called AI, they have very different AI requirements and vastly different levels of AI maturity. So what I want to do next is apply this framework across several industries to show how it can be used in practice to help guide decision making. So to determine what industries to dive deeper into, we wanted to look at startup activity as a signal for where there's significant innovation happening across the physical industries. And to do this, we used some of Lux's latest data science capabilities, which allowed us to search through our own database of over 1 million companies to find AI developers in 6 key physical industries that are shown here. And the benefit of using this methodology is it allows us to be completely comprehensive in our search, but it also allows us to be unbiased in seeing where the most activity is actually happening today. And what we see here is that 2 industries really bubble up to the top here after doing this analysis, which are healthcare and automotive. And we'll focus on these 2 for the remainder of the section. But that's not to say there's not significant opportunity in each of these other sectors, where we see a lot of activity happening in energy, manufacturing, chemicals and materials, and Lux is helping clients in each of these areas to help them identify what the AI opportunities are and to help them map their applications onto this framework. But for the purposes of this presentation, we'll focus on healthcare and automotive to show how this can really be used in practice. So what we've done here is mapped out, some of the key AI applications in healthcare. And for those who are more interested, we have an insight on our member portal, which goes into more detail about the specific methodology and calculations we used on how to place these on the framework. And what you can see is that besides some operational applications of AI in healthcare, most medically relevant applications of AI in healthcare fall into this complex side of the framework. And this again has to do with the inherent complexity of biology and medicine. And so we can pick out some examples here to show how you would use this framework. But one example where a lot of companies are trying to use AI is in drug discovery. And so specifically, there's a company called Benevolent AI that I want to talk about here. And while there are many companies targeting different areas of the drug discovery pipeline that would fall onto different parts of this framework to perform sort of end-to-end drug discovery, which is everything from generating hypotheses, from reading literature to predicting the results of clinical trials. This is going to require the capabilities that would fall into quadrant 4 of the quadrant to again accomplish that end-to-end drug discovery process. And we can compare this to something like IDX is targeting, which is using AI to diagnose diabetic retinopathy from pictures taken of a patient's eye. And again, because you're just trying to recognize a pattern in the available data, this falls into the complex side of a pattern recognition task. And we can look at some recent outcomes from these 2 companies to really see how this framework proves its value. we've seen that benevolent AI probably got a bit over its skis here when it cut its $2 billion valuation in half from the previous year alone. So, while I think AI will be very impactful for drug discovery in the long term, trying to do the end-to-end process as benevolent AI claimed was a bit too early stage, again, because it just fell into the quadrant where the AI tools are simply not mature enough yet. And we can compare this to IDX again, and because we believe they chose an application that was more mature, we're starting to see the benefits of that, where a recent study confirms that their AI software does not even require clinician supervision, and it's already achieved FDA approval. And the key takeaway here is to really, if AI is just being introduced into an industry, or you're just getting started with AI, to really pick off the lower hanging fruits in quadrants 1 and 2. And this is because the current capabilities of AI are best suited for pattern recognition tasks in both simple and increasingly complex environments. So this is a really great place to start and to get the low hanging fruit there. If we look at another application within the automotive industry, autonomous driving, we've mapped out some of the key variations and flavors of autonomy onto the framework. And you can see it ranges from more mature applications like driver monitoring all the way to full self-driving capabilities, which is much more in early development at this point. And the specific company I want to talk about here is Tesla, which recently rolled out its Smart Summon feature, which allows drivers to call their car to come to them autonomously in parking lots under the driver's remote supervision. And while initial results were sort of mixed, the media showed a few minor fender benders, which shouldn't be surprising given the level of reasoning required to navigate this situation. But really, I think the much bigger story is that they were able to accomplish 550,000 Smart Summon uses in just the first few days of deploying this alone, which I think really highlights the promise of this approach. And while we still think Tesla is a long way off from full self-driving capabilities, constraining the problem to just parking lots where there's some structure, the speeds are much slower, is actually a really solid approach here. And the key takeaway from this is to really build towards those applications with high AI requirements. So use applications in quadrants 3 and 4 as North Stars and deploy incremental solutions along the way. So whatever the self-driving equivalent is for your industry, don't wait until the capabilities are all the way there, but build incremental solutions, which allows you to collect data and learn so that you eventually can get to that desired end application. So with that, I want to leave with a few key takeaways. The first is to be successful with AI, really start with the end in mind. And this means laying out all of your dream use cases of AI and mapping them onto the framework to determine whether it actually can be accomplished with AI today or not, and what the timeline will be for that solution. The second takeaway would be to get quick wins by focusing on pattern recognition tasks. And so this often means constraining the problem to make it a better fit for today's AI tools. So things like enhancements, optimizations, upskilling, combining humans and machines together. But if you're just getting started with AI, don't go for full autonomy. Start with these more enhancement applications. And then finally, you want to balance the quick wins with taking a long-term approach towards building incrementally towards these large impact applications. You really want to take a long-term view with AI, as it is here to stay and is worth investing in for the long term.
Thank you, Cole. That was a very informative presentation. To me, it was very fascinating to see that the success and failure stories from both automotive and healthcare sectors aligned so well with the risk that the level of risk of for AI that you see in the framework itself. We have some questions coming in now from the audience, but before we get to that, just as a reminder to the audience, please use the questions box to enter your questions for the webinar, and if we have time, we'll get to those questions. One of the first questions is really around the process. It seems like the big challenge is not around just the framework, but figuring out where these different applications are sitting on that particular framework. Could you talk a little bit about the process that you use for figuring out where different applications should be on the framework?
Yeah, definitely. So, so now that we've applied this framework both generically for a number of AI applications, as well as specifically across a couple of verticals, we've learned a few lessons from using the framework. The first one would be that each industry really has nuances of how you use the framework, and what this means is that we really have to pair up with the subject matter expert to understand where these applications would fall and to understand the scoring system that we needed to develop. So in healthcare, for example, understanding data complexity meant incorporating aspects like population variability, lifestyle, nutrition variability, and so on and so forth. So really pairing up with a subject matter expert that knows what goes into these different applications. For understanding the level of reasoning of an application, you really just want to look at how a human currently solves the same task. So, in oil and gas, for example, we are able to look, does this accomplishing this, with humans, does this require just an individual? Can they do it really quickly? Or is this a team that, would require weeks of planning and analysis to accomplish? And then the last sort of key lesson that we've learned is that you really want to try to be as specific as possible with the application as you apply to the framework. So I wouldn't recommend mapping out AI for robotics because there are hundreds of different sub-applications of AI for robotics, and they all have vastly different properties from one another. So really try to be as specific as possible with the task and application as you apply it to the framework.
Thank you very much, Cole. So another question appears to be around failures in this area. So you talked a lot about selecting AI projects, but clearly we know, and many surveys have shown that a huge number of the AI projects actually end up failing. Can you talk a little bit about, when it comes to implementing these projects, what are the kinds of failures that happen? Where are people going wrong, actually?
Yeah, it's a great question. So I think what the framework really does is it's a great starting point and can also help you manage, if you're working on multiple AI projects, really understanding what your portfolio of AI initiatives look like. But it really is sort of only one step in being successful with AI. And in the report where we introduced this framework, we actually talk about some of the many challenges that go into successful implementation. Just to highlight a few here, I would say everyone focuses on actually training machine learning models or what machine learning model that they want to use, but it turns out that's really the easy part of an AI project. The more difficult and time-consuming steps actually happen before and after you train the AI model. So before, it's all about collecting the right data and getting access to the right data. I've never sort of been a huge fan of the data as the new oil analogy because it can be misleading in some ways. But in one sense, it's very appropriate because in the same way that you can't just take crude oil out of the ground and put it in your car and expect it to work, most of the data that you have flying around is not ready to be used in machine learning applications. You have to first get access to the data, you have to clean it, label it, make sure it's unbiased, so on and so forth. And we've looked at some emerging tools that can help address these problems, things like automated data cleaning, and we recommend to clients to start exploring such tools. I would say when it comes to deployment, so after you've trained the model and you're actually trying to deploy it, there are of course technical issues like model drift and so on. But I would actually say many of the challenges are more cultural and around integrating it into processes so that it gets adopted. We've worked with some clients who have built AI solutions only to find that their engineers and their employees don't actually trust the results of the AI models, or doctors do not want to trust the predictions that these machines make. So I would say that if you're building AI, you should really spend a lot more time at the beginning of a project, really thinking through how it will get adopted and eventually integrated into a process.
Thanks a lot. It appears as if some of our audience members are very interested in Quadrant 4 applications. Could you talk a little bit about some emerging technologies that you think will help unlock some of these high-risk applications or moonshot applications as you were mentioning?
Mm-hmm. Yeah, so again, we believe many of the applications that would fall in that quadrant 4 are still, quite a ways out. But there are some interesting technologies that we're watching very closely at Lux that could eventually, as you mentioned, unlock those types of applications. Just to highlight two that we think are really interesting and have the potential to be really compelling are one is generative adversarial networks, or as many call them, GANs. And just to simplify a pretty complex topic, you have two competing neural networks side by side. One is generating data, and the other is evaluating that data to see how realistic that data is. And it's through this sort of iterative feedback process that you can actually unlock applications that would typically require that reasoning capability. So we've seen things like being able to generate audio or generate images, and even more emerging applications like generating healthcare data like MRIs or even new molecules or chemicals. And so that's a really interesting application and one that or technology and one we're watching very closely. The last one would be reinforcement learning. And we saw a big wave of hype around reinforcement learning after AlphaGo, which was a AI program that beat the best Go player in the world at the time. But the big problem with actually implementing this in real-world solutions is there were just massive data requirements that were much more difficult to collect in real-world circumstances rather than in a game. So we're starting to see progress there, especially in areas like robotics, where you can get pretty accurate simulations of the environment, and that's certainly another technology we're recommending clients watch closely.
Great. We are out of time now. Once again, thank you very much, Cole. If you have any questions about this webinar or about the content we presented today or about Lux or how we work at Lux, please email us directly at questions@luxresearch.com, luxresearchinc.com, and someone will get back to you shortly. If you have submitted a question and we did not get to that question today, rest assured, we will get in touch with you regarding that question. You can also follow us on LinkedIn and Twitter, or follow our blog at luxresearchinc.com for ongoing insights on what's happening on the technology end or what's happening in markets. Thank you again for your attention, and thanks again to our presenter, Cole McCollum. Have a great day. Thank you.